Late night stream. Where's my face? Oh, camera is off. Here's my face. I'm back. Yeah. So, you are back or you are new to today's streaming sessions. I thought it's 1 o'clock in the morning, so what's the best to do at this time? No, not, not what you think. I know the meme. It's time for PCB Design. Here we go. Where's the chat? Do I have a chat? Oh yeah, there is no one in the chat and no chat message. Let's test if it's running again. Oh, hi Philip. Can we see Philip here? Yeah, here he is. Philip, you are here. So probably there are some people that suffer from insomnia. Unfortunately, I can't let some music run. I usually would use music to do some. Ah, hi Sienna Gertz. Okay. Is everything all right with the stream? I don't know. Nightshift. Ah. Ein bisschen spät. So, since we are only Germans, yet. I don't know. My girlfriend is watching the Oscar not nominations, Oscar Academy Awards upstairs. I thought I will do some sessions. My usual like I go usually at 3 o'clock to bed, from around 3 or to 5 o'clock in the morning to bed. So still plenty of time. Kohina Radio. What is Kohina Radio? Yeah, so I usually would listen to some music, but I can't on the stream. Oh, chip tunes for old games. But I don't know if the people, since I will probably talk all the time. I don't know if it's annoying at the end. Kohina Radio. Never used that on the stream. Maybe I should try. Let's try. Kohina Radio. And then I get like claims. Are you sure that this is free music, or do I get claims, copyright strikes or something? Oh, maintenance, web player. Oh, here. Stream. Let's see if we can get some radio here. That's cool. Oh, that's over dribble, sorry. Oh, which one is? So what do we have? Pretzels Rock is licensed for streaming. Yeah, I saw it. Oh, okay. Okay, we will try it another time. I have like to check what's legal and what's okay on the stream. I trust you, but I want to pick maybe some songs. I could run all the time here. This what is this? My here, that one. Let me add this. Is it playing? No? Yeah, it's playing. Power up. That's the that's the tune I'm using. But actually the dude that did this music for the YouTube library is super cool. He's a YouTuber himself with like 250,000 subs, and he does really great tutorials, and he's such a great talented musician. Name is Andrew Blake, and his channel is some kind blah blah recordings. Oh, I'm sorry, I can't give him a proper. No, Andrew Blake was another guy, this porn dude. Oh, I will check here on the screen. I will give you the name. Oh no, that's my script. Jeremy Blake, is it? Jeremy? No, Jeremy. Yeah, it's Jeremy Blake, and his channel is like something with M. Help me, please. I found his cover. This is Jeremy's SoundCloud. Where is his? YouTube. Yeah. Yeah, red means recording. That's it. Yeah, thanks. Yeah. So and the last tutorial. So actually, what I wanted, I'm working on MIDI synthesizers right now, and Jeremy does like this tutorial where he uses this tool, Synthorial, where you learn the basics about synthesizers. And I have started to write a script about the basics, because you need to have like okay, that's like the short version, and I have like another version that's more complicated, also covering like all the USB MIDI stuff. And actually I'm working at a similar thing, but I want to show the actual, maybe on the oscilloscope, what how the waveforms look like and how we modify it. But he does a really cool job on his channel, so subscribe to Red Means Recording. Oh yeah, Pretzel. Citrix disaster area. No. I know nothing. I'm like Jon Snow. Oh, it's so warm inside. I have to... Strip again. Okay, yeah, the last stream I was like 2 hours talking, and then the last half an hour I was designing this board. We were almost finished. Yeah, FM synthesizers, I don't like the sound. Actually, I don't like the sound of FM synthesizers. But okay, our Citrix disaster area. Sega Saturn hacking pretty. Yeah, yeah. Unfortunately, uh, since we came to Germany like 88, and then we've been like poor for quite some time. And in Poland, where I was born, um, there was like a C64 scene, but it was socialism, and there was not much access to computers for like uh, regular people. And we were poor in Germany until like the 90s, where I got like I started with PC, and that's all I got. I was always like a PC guy. Okay, I will give like recap what we did in the stream before. We had like I have designed, or I started with the schematics of two new boards that I am working on. The MIDI synthesizer, that's this one. Um, ESP 32 rover module with extra RAM and SD card slot here, and yeah, headphone jack, and actually an amplifier for headphones. Is like a AB class amplifier, which I didn't have before on my boards. It was always like only line out, because the internal decks aren't very powerful, at least not for driving like external speakers. And that one is super cool, since it has like the charge pump inside, and it will actually produce output signal here, L and R, which don't require any caps, but the caps are on the input side. That's really unfortunate, since we need like to take care that the cap is picked correctly and so on. But yeah, I hope this works out. And the other sheet was only like the USB host chip, where I will connect all my MIDI devices, like here the Akai MIDI stuff. And that one is like the huge new synthesizer board. This is the Pro version, since it has the SD card slot for like MIDI files and maybe samples, and extra RAM for samples like wavetables or something. And there will be a simpler version without the RAM and without SD cards, just smaller. And another thing, where is it here? What I built is like without ESP32, only with the CH559T. I bought like how many I had, like where's my shopping overview here? Yeah, 52 two pieces of this T version. I thought I take a simpler pin pitch and fewer pins, but unfortunately this one has only like one host port. I didn't see it before I ordered. I'm really bad at this. Okay, so oh, cool. Disaster area. Okay. Yeah, yeah, they did. They did. So actually, there are only like two so one pair of the USB pins, and spare like GPIO for whatever reason. Haha. Hi René. Ach, René Bohne. So René, will you be on the Maker Fair again? Sure you will. Yeah, and this since it's 8 bits with like 48 megahertz processor, doesn't have memory, but it doesn't need any if it's like a simple synth with like few notes, polyphony, and maybe ADSR or something. Uh, it had still some GPIOs. Mardenman. Who is Mardenman? No, where's Mardenman? Okay, so we had some spare GPIOs. So I thought I do like an external deck, like a resistor, 8-bit resistor ladder, and then we added, yeah, this is like a mono amplifier, but it's a D-class amplifier. Yeah, you got confused. No, René is like, which he's a maker from yeah, René, introduce yourself. I met him at some maker fairs already. Okay, so we have like this D-class amplifier that will like blast away your ears if you connect it to headphones, probably. So that's that's why, since 8 bits is not as that many, so you could like do volume control in software, we added like voltage divider here, and bigger caps, and yeah, we are hoping that this somehow give an output, but we also added the header here, or like two holes, pin holes, where you can connect an external speaker if you wish to. So you get like, this should be a base for like a simple 8-bit synthesizer that you simply connect one MIDI device to. And yeah, we finished the PCB. I prepared it before yesterday night, and what we have is power from USB. So D plus, D minus is connected via 200 ohms resistor to get the maximum power from USB. Then we have the output jack, where left and right channel are simply connected together. I don't know if I could like do differential output, or no, not differential. How is it called? Like when one channel is inversed. I forgot it. And here's where you can connect the like an external speaker if you like. This is the amplifier. It's really tight. All the resistors are here, and here is a connector to program it and test it. And here is the USB. Here's a button to program manually if you don't use the connector here. And this is the IC. So this board is small, very small. Not, yeah, 2.5 millimeters in width, and height is like 35, 40 millimeters, something like that. So it will be a really tiny board. You can power it from like a power bank. Probably not a cheap one, which introduces much noise. And what was missing here is we missing some labels for the connector. Yeah. Aachen. Oh, really, Rene? You are working on ESP32 MIDI projects? No, you aren't. You liar. What are you using for like show off what you have done with MIDI on ESP32? Not synthesizer. Oh, okay. So like BLE and Wi-Fi. Okay. CM choke with the USB power input. What? I'm exposed as a noob right now because yeah, a choke. Inline inductor, like here connected to the 5 volts, you mean? Yeah, no, that won't happen for this super cheap board here. Common mode choke. Let's Google common. Images? Yeah. Ah, yeah, okay. These are the power lines. Oh, interesting. Oh. Okay. So what it does, it neutralizes itself, like the noises or what? Ah, interesting. Yeah, but it's something I don't really have to care about. You can buy like a USB cable that has has this feature. Let's see if LCSC has some chokes. Inductors, chokes, common mode chokes and filters. It's as easy as that. So, oh, whoa, okay. Same musical skills. You mean none? Okay, okay. I challenge you. How many MIDI devices do you have? I can count them. I can count them. Okay. I have. Let's start. And I probably forgot about some. I sold even the huge keyboard because it was really too heavy and I didn't like it anymore. So I like this one here. This like Elasis Q49. It has like the keys are so light and you can really easily play that. And it doesn't have any features except you still have like the classic MIDI output and USB. And it's so simple, but it's so great. This is my first one. Then I got that one, Bluetooth, but Windows doesn't support Bluetooth. Bluetooth MIDI. This is a built-in arpeggiator, Akai LPK25. So that's like for traveling. It's like a super. It's light and you can power it from batteries here. So that's quite cool. Battery powered, but usually all of the devices you can power from like a power bank or something. Then my absolute favorite one, the Key 25. It has like the buttons are lit, only 2 colors unfortunately, and no like velocity, but it has like controls, it has many buttons and keys. I don't like how the pressure increases. Also, you have like the resistance increases when you press them down, but that's the same problem with all the Akai keys. I don't know, it's like a rubbery keys, and but it's overall, it's I think the best one for traveling. It simply fits in a small backpack, and you can have a ton of fun with this one. So that was the third. Then we have here simple Korg controls, like only sliders and stuff. That's the fourth. Then we have the Akai Launchpad with volume controls and more buttons. But this one has like with the lights, it's like the light is multiplexed, and it has some problems with several lights. It isn't perfect. And this is the one, the least favorite one. It's like the fifth. The sixth is this one. That's the third favorite. So when I'm doing music, I'm using this actually for controlling volume and effects and stuff like that, and the small one for one instrument and the large keyboard for the other instrument. So these are 6 MIDI devices already, and back there my self-built organ pedals. That's like that's like 7th MIDI device. Okay, you won. Novation Launchpad. Oh, you're a crazy person. That's like 400 euros, isn't it? Hi, Sion. Oh, yeah, no, I don't want to like to put like trash on my main channel. I like to have like condensed information there. So this stream will stay here, but at some point I will also start streaming on the main channel from time to time. I don't know how I will do it, but more like planned streams. So this will stay on this trash channel. OP1 costs. I don't know OP1. What's the OP1? Oh yeah, that's the night. I saw that quite often. It's a really liked one. It's also like several hundred euros, isn't it? No. Yeah, I'm a cheaper. I scale my expenses to my talent in this case. But I spent 450 for Ableton full studio version or something. Oh wow, crazy. Okay, enough bragging here. Whoops, that's Twitter. No. We have been common mode chokes. So, what kind of choke do we use to filter power on the USB? Where's my choke here? Where's my search with the chokes? That's not my chokes. That's not chokes. Yeah, that's chokes. Yeah, Ableton rocks because yeah, it's easy to use and it's a great software. So anyone knows which one to use for What specs do I need to filter power? I will just put it in my basket. So next time I order something, I will get the chokes. This stream is not sponsored by Schwipschwap. How much current? So we have at most on this board, it will be, let me check this. How is your Chinese? No. Pam, blah, 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 blah. So we have for the output power, we have like 2.5 watts max plus driving a keyboard. Let's check it. No power consumption here. This isn't either, but let's assume that's an no, that's the LEDs are multiplexed. We can't calculate like this. But I assume this will like take maybe, since it has to be USB compliant. How much is half an amp? Yeah, the keyboard is powered by the USB host. So I will connect my device to here and power like to the side of the device, and the power will like flow through the host to the MIDI keyboard and also to the speaker. So we will have like probably 1 amp. Hello, the Pixel Mint. Oh, cool. Yeah, that's cool. What's MIDI? Oscillator. Hello, Daniels. MIDI via OS. Oh yeah, MIDI. Via what? OSC? Yeah, so that's similar to my mallet spot. Oh yeah, the mallet spot is another MIDI device, but it's an output device. So that's the 8th device that I own. Open sound control. Oh, okay. I don't know what to open sound control. Let's open sound control. Okay, interesting. That's something to read for later or watch videos on that topic. So, okay, no choke, right? Oh, did you Sienna, did you calculate the choke we need now with 1 amp? I don't know how to do that. I'm a real noob. I am an imposter. Current rating, maximum. Oh yeah, we need a current rating of, let's say, 1 amp. Should we do like 2 amps? 2 amps and maybe surface mount? Volt DC. What? Withstanding voltage. Oh yeah, so for peaks or what? Yeah, we don't need that. That's way too high. We don't need any protection for like super crazy. Here, 30 volts DC. We found something. Here it is. SMD. But it's huge. This is 1 centimeter. Are you crazy? I will never put this on my board. No. That won't happen. Number of lines. 2 lines. It is, isn't it? Yes. Ground and power. Okay, okay. So let's reset this and reset this. Power line. Oh yeah, we have power line here. Oh, cool. Maybe this will... Okay, power line, number of lines, voltage rating. Yeah, nobody needs voltage ratings here. Oh, yeah, we have here 0805. That's cool. How much current do we get here? 6 cents for one. Oh, you can see here 6 cents. Are you crazy? That's way too expensive. You have to piss all capacitance. Oh. Oh. Where do you know all this stuff from? Yes, I am cheap. So okay. Maximum capacitance. Capacitance that I have like, let's check it. We have some nanofarads here. We have like 10 microfarads, 10 microfarads. That's like 20. Here's another one. Oh no, these are only filters, but they are maybe important. I would say on this board it's not like 100 microfarads. It's less than that. What? Give up? No! No, please don't give up. Please help me. Help! I'm a cat. Help! Okay, okay. How do I calculate it? Where is the capacitance that what are the values that I need? I will like okay, yeah. All right. Okay. Yeah, but that's an extra super premium feature anyways. We will only use that if it's really really noisy, but it could be noisy with the multiplexed lit buttons on the launchpad. Microfarads. So you mean with 100 microfarads should be like covered by this one here or what? Can you even read it? I maybe zoom in a bit. So this is, since I don't want like a super huge one, power line, number of lines, 67 ohms at 100, 400 milliamps. Ooh. That is below what I will like if I want to drive a speaker. That's below the rating that I need. Yeah. That's all we get, or what? Okay. Do we have, we can sort by this here, can we? No, we can't. How much inductance? I don't see it. Let's check the data sheet here. Let's check the data sheet. Ooh, it looks neat, isn't it here? Values. Where's the inductance? I don't see the inductance. Yeah, good luck with that. You have to recompile that kernel, Michael. Impedance, 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 inductor. No, nothing there. I don't know what this does. I don't know what all this means. Okay, is there another footprint here? Do we get like smaller footprints? Or let's take a cheaper one. No, they are all like 6 cents. It really doesn't matter. Out of stock, out of stock. It's all MTech. How they differ here? Type and real. Okay, type 900 ohms, 260 ohms. Yeah, current rating. We have all the current ratings here. Yeah, 450. They have 450. That will be like barely enough to drive anything here. Okay, so we'll put like, how many should we put in the basket? 110? Pew! Do we get like a better price for? Yeah, $5. That's something I could invest. So I don't forget to try this at some point. Yeah, good luck, Michael, with your Linux kernel. Okay, let's forget about the inductors. We want PCB design here. Thanks for the help. I wanted to fix some issues with the board. Let's take a look at the bottom here. So we want this side to be filled. We move this here up. And do we get a fill in here? That will be really close. Like that, probably. No. Is it? Will it work? Let's refill. Oops. The chat is in the way, isn't it? Wait a second. Move it. Okay. Whoops. Rebuild copper area. Yeah. Okay, we have now a fill. Now we have a nice antenna here. So what's the top layer? We might need to add top, bottom, top. Why isn't it responding? What the freak? No, not the part. Ah, yeah, okay. I seem to be tired. Let's do it like this. Okay. Oh yeah, there is nothing. There's no place we could like. Yeah, we leave it like that. So we get a small antenna there. But What's a lytic? What's lytic? Electrolytic. Oh. That's like a super nerdy slang here. Okay, electrolytic. Yeah, but why? Give me one reason why I need an electrolytic capacitor. I know that the response of like ceramic capacitors and electrolytic are a little bit different, but please elaborate why or how does it help here in this case. Meanwhile, I will top silk layer, remove this, and I will add some artwork. That's the only thing I could do here. So we have some labels. What? Oof. I'm on the wrong layer here. Bottom silk layer. Which tool are you using? Whoa, the storm is crazy outside. It's like really tearing everything apart. Is it too small? No. Yeah, it's a bit small. I don't think JLC would be able to print that. Okay, so let's make it bigger. Height would be like 0.6 millimeters. Cranky if they don't have enough capacitance input side. The ceramics cover just as spikiest those spikes. Okay. Yeah, you're right. Pam. I even received some PAM boards here. Where is it? This is not. I got some boards. Where are they? Yeah, my intention wasn't to drive huge speakers with that. I just wanted to have like an amplified output, but yeah, now that we added also like a connector to add like a small speaker, you might be right to. I don't know. Yeah, I don't know. You know what? It's a freaking 8-bit mono synthesizer that is only able to like play square wave or sawtooth. What do you expect? It won't sound like a super smooth Jean-Michel Jarre synthesizer. It's not a bug, it's a feature if it's like super cranky. at the end it will be just super stupid square wave. It will add to the quality of the sound. It's like a filter. It's a natural filter where we get like a attenuation or something on the square wave. It will get like this dirty sound, like this. And no worries, you can piss on my parade anytime. I wouldn't stream if I would like to do it on my own here. Okay, so we were adding some labels here. There's no space on the top layer, isn't it? Yeah. It would be best to put it on the top layer though. Top silk layer. Layer is invisible. Okay, so which way around? This way around is good. Maybe a bit smaller. Let's try with 0.5 millimeter. Nobody will be able to read that. Or this is RX. Oh, damn. Yeah, no, this is not readable. Yeah, noisy sounds. That's what we want. This board won't be even sold. Like I don't it's not my intention to sell this board for hundreds of pieces or something. It's just because I bought the wrong controllers. We should rather spend more time designing the other board. It's more interesting. But I will finish that and put it like in to order. It's a 5-volt, or no, let's call it VCC. And this is reset. How do we call reset? R is taken for RX already. Reset, enable. What's inverse enable? Yeah, I will just call it enable, whatever. And this is P like programming, or B like bootloader. It's better. Okay. It's like super janky here. It's not on the same level. Okay, we have the labels. missing some labels here. Now let's call it a different speaker. Speaker like that, then we don't need any speaker, and that's all. Wait, maybe some text on here. So what's the name of this product? You get the chance to give it a name. Otherwise, I will pick one. I will call it cramp. MIDI cramp. Yeah, that's the best. MIDI cramp. A thing. 0.9. Yeah, you are too late with your thing. It's MIDI cramp. It's MIDI cramp now. Headache maker. CMOS version, City. Wow. Yeah, but do you have like Groovebox? Do I have a long delay on my stream? I thought I set like a super fast delay. Oh, that's unfortunate. You guys are a little bit delayed. I am sorry about that. I thought it will keep my settings from the stream before. So it's like MIDI cramp. I will keep cramp. I'm sorry, guys. It's too cool. Too cool of a name. Like, and this one can be 0.8. Doesn't need to be such big. 0.8 like that. So we know MIDI cramp. Woohoo! Done. Here a bitluni logo. Where do I have my logos? Import image. Now I will expose all my files here. Do I have I just need a bitluni logo without any other stuff. A clean bitluni logo. Not possible, isn't? I can't get one. Okay, so let's take bitluni's lab instead. What are the best settings for that? Color tolerance. No tolerance. Simplify level. No simplification. Corner threshold. Ooh, that's crappy. Yeah. No simplification. Color tolerance. This import sucks really bad. And how big should it be? We want one here, let's say 2 centimeter image size in millimeters, 20 millimeters by 23. Oh, okay, that's the wrong layer. Bottom, no, not bottom layer, bottom silk layer, MIDI cramp. It's really like it looks shitty as look at this. Why is it so simplified? Oh, Daniels. Oh, I'm so sorry. Mm. Yeah, nobody cares about that probably. Top silk layer. How does it look like? Yeah, why is that so shitty? I don't want that. I want a proper import. I'll import it separately. I think they use only like a fixed number of points for that. So I will like it's the storm is so bad. Here, that's the flat logo. And I want 20 millimeters. Ugh. Again, wrong layer. Bottom silk layer like that. Here we go. That's cool enough. You know what? We don't have any mounting holes. Yeah, but who cares? Okay, let's try import again. Can we find this again here? Flat logo. Yeah, actually plenty of artwork here. Logo flat. And this was the one that I imported, but I don't like the simplified edges. I don't know why. It's not very complex. Why do I have like this crazy simplification? Oh, that looks better. It's like a little bit, yeah, I like this much better now. Okay, 20. Let's do it all over again. And this can be removed now, and this is the bottom silk layer, like that. Again, do we have like a bitluni slab? This one here. That looks okay. Oh, yeah, wrong size. Import image again. Is there a flat version? Flat, yeah, that's the flat version. And image size 20 again. I should simply switch to the bottom silk layer in the first place, so I don't have to change this every single time again. Let's move it up a bit. bitluni slab. Like that. Arrow keys are really helpful here. Hello, Dragon. Yeah, I decided to do my channel in English because I thought I will reach much more people than in German. But actually, I see other makers, other German makers, are also quite successful and pass 1 million subs, and it's way easier to do like German content, I believe at least. So I could like talk to the camera more easily and do like single take videos rather than writing scripts and stuff like that. So I'm not sure about the decision, but I met quite a lot of international people already and got many friends there. So I don't regret my decision. It's like, I don't know. Yeah. Yeah, probably compared to your German, probably it is. Danke, Sion. So what was the yeah, MIDI cramp was the name here. MIDI cramp. This name is so hilarious. Don't you think, guys? It's super hilarious, the name. MIDI cramp. Line width. Ab und zu Deutsch sprechen. I thought about making one video completely in German with English subs. So that's a typical thing to do for like foreign or non-native English YouTube channels, to do at least one video in their common language. So what do we have? Oh, I need to copy that. So like that, and version. What was the version? Coders will get it, probably. I need to or make it smaller. Yeah, I need to make it smaller, yeah. It was really weird, yeah. So for the non-coders, I think, I don't know, I'm not sure if it's 0.1 can in like floating point, it can be represented by floating point actually, like precisely. So it's like 89999F stands for like C++ floating point. That's such a stupid coder joke here. Do we need a mounting hole, or like for to carry it as a badge, like a hole? I think we have some space here, some room in one of the corners, so we could place a hole there. Where is my silk layer? Oh, yeah, there's no space if we have the label here. MIDI cramp. So maybe we put the speaker down here and put on the MIDI cramp over there. smaller. Yeah. Like that. Maybe this a bit smaller. Yeah, this font is even bigger than. Oh, we need more jokes, more fun here. Is there something we could hide, like underneath a connector? Like a dong. Hide a dong beneath the connector or something. Demonetized. Okay. So this could be, yeah, and then it is like, okay, I need to move this via here, like over there, and put another one here. And maybe, oh, this is like the super stupid edge here. Oh yeah, that doesn't work that nicely in this software. Yeah, we will make like a round edge here, maybe like that. Oh, not round, but what happened here? Oh yeah, that works. Like that. Or maybe a bigger hole. So we could make a badge here out of this. What's the diameter? What is this hole? 3 millimeters. Is it a nice diameter? Then we have to move this again a bit. This could be like a synthesizer badge or something. But since you need like an external power supply, it probably isn't, so who cares? Okay, let's rebuild the copper areas again. Oh, that's really close to the edge. That's like, I don't fear that this should work like that. Yeah, you know what? Who cares? I will just do it like that, and if it doesn't work, then it doesn't work. Then it's simply inconvenient to use. Okay. Is it okay? No, nothing caught on fire yet. I try to decide on the hole size. So let's check what we have here. This is, yeah, 3 millimeters is okay. But I feel it's really flimsy. This could break if I hang it or something. Oh, ZX Spectrum. 1 millimeter. Is 1 millimeter enough to be a durable hole? What do you think? Yeah, but we have the speaker connection here. There is no space. Or make it smaller, 2.5 millimeters. And I don't care if it doesn't fit anything. Yeah, like that. Okay, let's check if it's possible to use it as a badge then. won't be. So let's zoom out a bit, maybe. So how thick is this here? Oh, yeah, we can use the ruler. You can use the ruler. We have the hole diameters here. Yeah, 2.26 actually works. Look at this. You probably have this ruler as well somewhere. So that's a 2.26 millimeter hole. That's okay. So 2.5 will be okay there. Hole glue. Okay, I feel like we spent way too much energy on this board. But at least you saw how I design my boards. So we are done with this one, I think. I will check now that we have, if we didn't screw up, since this tends to happen quite often. I will add this wire again here. We have, it's like one additional wire here. Now we, no, the design manager. Don't want parts here. Check for DRC, nets are all done, everything is all right. Okay. So save it. Oops. Save it. No, I live in the center of Germany, like close to Bad Hersfeld. Bad Hersfeld and Fulda are close to me, like I'm right in between. It's like in the middle of nowhere. Okay, so we have saved it and I will put it in my basket for a JC PCB order. But I don't know, I export the Gerber files. Where are the Gerber files? Yes. Oh, I forgot something. Oh, thanks. Yeah, I take it as a compliment. Or was it like an actor for like awful role? 3D view. Yeah, we need to check if we messed up here. Okay, we have some labels. This looks shitty here. Look at that. What is that? I don't see what you see here. What's that? Oops. What? Oh yeah, we moved that. Oh, I want to add like a small bitluni logo here. We have some space here left. A micro, 1 mega. This could be smaller. This is 0 ohms. This is 1 mega ohms. 0, 10. This is smaller. A few aesthetics. I don't think that JC will be able to print these labels here. It's way too small. It's below their capabilities. I'm curious if the silk screen will continue over here, overlap this board when we penalize it. Okay, and on the other side, yeah. Hey, why is it flipped? What the heck? Why? We have ball zinolitp. Okay, that's an error. Oops. Yeah, that's right. Okay, so better check the first time. Move this up. This is the same size. This is too big. 0.5 is the right size. Oh no. 0.5, 0.6 it is. Like this, 0.6 millimeters. Like this. U2, this U2 seems a little bit huge. Why not hand assembled? Okay, hear me out. I'm a pro. This is definitively hand assemblable, because I will show you. Look at this. I learned a lesson from all the boards that I designed before, like that. All the same resistors, like 20K, are grouped in one row. I only have to place like pick. Okay, we can solder it maybe. Only like with hot air, but with stencil and stuff like that. Oh, do I need to order stencils? Yeah, I need to order stencils for that. But you can simply, this is one type, then we have a space, so we see this is the 0 ohm, this is 1 mega ohm. This is especially optimized for hand assembly, since I don't like label it R1, R2 and whatever. I actually write the actual value here. And we have 0 ohms, then 10 micros. So when I pull out like all the, this is the too big size here, 6. Pull out like all my resistors and capacitors, I immediately see where to put which value, and that this is quite helpful. Might help you as well if you're doing it like that. Hand placement is okay, yeah. Yeah, I know. Soldering with a soldering iron won't be possible here. But I've really like, I rather found out that I like doing like hot air on SMT parts. Hot air is simpler than soldering by hand. I don't know if yeah, we will try. We will do it live. So subscribe to Trash if you haven't yet, since we will do it live on Trash here. Okay, let's add another image file. What's the time? 2:30. You guys aren't sleeping yet. And we want, what size do we want? We want like, this is 2.5 millimeters. I'm not sure if they will be even able to, oops, if they will be able to, ooh, yeah, it's small. To print this properly, but it's a simple silk screen. Shouldn't it be like that? Yeah, that's cool. So we even filled that one here. Okay. What's this all? Oh yeah, no, we have this the flipped logos here. Locked with location. Where's, how do I flip it? It's the wrong negative width. No, doesn't work. Yeah, small. I have even like a dual I2S dual 16-bit DAC. I have even like ton of these chips here. actually I have hundreds of these here. You see me in the comfy clothes here, but I'm a YouTuber. I wear only comfy clothes all the day. So the part number is PT8211. Do you know that one? PT8211. Ah, look at this. It's like a super cheap ass. Where's the data sheet? We probably have this even on LCSC. So, and I wrote for the I wrote even like a super simple I2S. Yeah, that's the chip. It costs 22 cents. And Princeton pack. And it has two built-in resistor networks. You know what? I don't know why. Why do I even build an external resistor? TDA 1311? I don't know what. YouTubers don't have legs. I don't know why I even design like an external resistor ladder. Damn, you caught me. Dude, we could totally make it like a 16-bit version of that. With stereo, but we don't have the memory for 16-bit. I think. Oh yeah, but it actually you can simply since this is like I2S, you can simply send the highest significant bits first, and then do the word select, and it will simply fill in the lower bits with zeros. To further suppress residual noise. Low pass filter after analog output. Okay, please refer circuit. Simple second order analog post filter. So this is 1 nanofarads here. 7. Okay, yeah. And then amplifier. Wow, but it's like additional parts. What is the TDA 1311? Is it better though? $10 ohms. Oh, that's interesting. Look at this. You have like here a 10 ohms resistor to make the caps here really effective. But look at this. Everything is here like an electrolytic cap. What? Never. I'll never use electrolytic caps here. Oh, yeah, okay. Yeah, but it's a neat chip. It's quite small. It has everything. What I really miss is that it has like an proper like driver for the output for like headphones or something. There are some ICs I found on LCSC like codecs that actually even support input output, but they are like you have like a ton of external components. No one likes that. No one wants that. Left channel, right channel. Okay. Wait a second. No. It's like external resistor, block diagram. Okay. What I don't understand, okay, they have like additional filters here. Like, oh, I don't know this. This is like adding another op amp and a bunch of components. Hello, Christian. No, yeah, I don't know if I would like to eliminate. Can we drive headphones with like a regular op amp? Is it possible? Yeah, you're right. So actually, but the PAM, okay, let's assume we would swap this PAM here, this class D amplifier, for the class AB's amplifier here. Then but we still need like some caps here in front, but I don't know which one. So how do we have like that's so much research. I'm not a research guy. I just want to try out, and if it works, I crank out a video. Do we have any notes on input impedance or output impedance or something? What's the sports input level? Okay, let's finish one board first, and then we will try this one, and we will build another board supporting like Princeton Tech. What's the 1308? Which one was this? Oops. Which one is 1308? Okay, we wanted to flip this here. How do I flip it? Do we have like here, rotate, flip horizontally? Yes, please. And flip horizontally, easy as that. So save it and 3D view. Yeah, okay. So MIDI cramp V0.9 speaker. Do I have to do like a plus minus here for the speaker? Does it really matter? Yeah, it matters if we connect something else like yeah. Okay, I will add this. Where's my PCB? So we have negative, positive, and so I will add a plus here. A simple small text with a plus. Do we have the right layer, top, bottom, silk layer, and we will add here a plus. Plus, and maybe a minus. No, let's do it properly. Plus and minus like that. Oh, it's inverted again, guys. Oh yeah, we are the wrong layer. Top silk layer. That's what we want. And we want top. What? Where are we? Positive, negative. like that. Is that all right? No, one space more. Okay, like that. Princeton tag. Yeah. But TDA is discontinued or what? And what's the PT 238? What's that? Data sheet. Oh, that's like a super crappy old data sheet. Oh. How come you know all this stuff? AB stereo headphone driver chip. Yeah. But is it capless? No, it isn't. Is it? No, it isn't. V out. Yeah, I want a capless one. That's why I picked the other one. But looks neat. Now with an... You know what would be the best? Capless output. Look at these filters here. What the heck? Can't you just put this on the die? It's crazy. Why should I put like the ton of stuff here? Do not want. Especially if this should be like electrolytic. I don't know, they use only... I didn't see like a ceramic type here anywhere. Maybe they use like this as a common... No, it's even like here polarity is even designated. So it has to be an electrolytic capacitor. No. Ooh, Kepler's virtual ground. Yeah, that's sexy, isn't it? And that's actually what this beauty does here. PAM 8908 here with a charge pump, but the input is kept. So we have like a low pass, like a high pass there, unfortunately. Ignore half the things. Yeah, but not the output cap. Okay, we are distracted again. Okay, last 3D view. Okay, does it look proper here? Yeah, this is still bigger than this one. Oh, I do not like. It's like huge here and then smaller here and tiny over here. Okay, let's trigger some OCDs. Shall we? We need some more fun on crappy bots like this one here that will never see the sunlight properly. Rotation 5 degrees, like okay, -5 like this. Okay, 5 maybe. Is 10 too much? It isn't so subtle, isn't it? Okay, I will leave that one like tilted 10 degree. This okay, okay. Last look. This is like this is like stabbing someone in the eye. Oh, beautiful. And this hoe here as well, but who cares? Yeah, that's okay. MIDI cramp. Yeah, cool, cool. Oh, we are missing the speaker label on the. Ah, but who cares? It's a nice clean board now. Let's leave it like that. MIDI cramp is done. Okay. So let's export it. Shall I put it in my bar? Oh no, we forget penalizing here. Penalize and vcuts. 3 boards. No, 4 boards, 4 columns. Whoops. 2 rows, is it? 2 rows, create border, yes, top, bottom, yeah. Apply. Like that. And now we have 8 boards. That should be fine. Oh, there is some spacing in between the cuts now. No place for that. No, there's no place for that. Or do they support more than 10 by 10 with the cheap rate? Secret picture, yeah. No, I don't want like column spacing, and row spacing will be 0. Like that. This is true hole anyway, so this could be even placed. Oh, but we will, okay, this will overlap here. But we have the positioning anyways. We can use this position holes here. That's okay. So how big is this board? No one knows. Let's export it and try something else. Okay. Gerber. Yeah, whatever. Okay, Gerber files are downloaded, and I will also put it in my basket on JC. $5 are enough? $2. Yeah, since this is a crappy bot anyways. And 5 times how many do we have? Times 8, 40 boards, and we have only like 52 of these amplifiers. That's enough for now. Green solder mask. Should we take a different solder mask? I mean PCB color, not solder mask. Like, if I take a different color, it will take longer probably, doesn't it? Okay, let's say put it in a basket. Okay, what's the board size? It's determined to be, yeah, 82 by 100 millimeters. Okay, PCB 3 to 4 days. Probably because they are really booked out right now. Yeah, color doesn't matter. Guys, we should take like a new color. What do you mean? PAM 8908? Which one? Is this the one that we are using here? No, A302. PAM, the other one is only for headphones. This is only headphone output. It should be like, I want only like a line out that is also capable of driving like headphones. Is this all right? Hello, Angel D. Mercedes. Thanks. Do you want a close-up? My beautiful eyes. I'm getting noticeably red here. Yeah, because of the light. The light is really, really hefty. I have like super, super bright light here. The speaker isn't connected to this one. This is another board. You're mixing up. There is like only a headphone jack on this board. What we are doing right now is this here. And that's the PAM 8302. That's a class D amplifier. And this is a class AB amplifier on the other synth, the Serious Synth. Oh, we have a working title, Serious Synth. Serious Synth. Okay, cool. Thanks. Okay, and that one is only for headphones and line out. It was really just because I ordered this board is like an accident. I ordered like this class D amplifier by accident, and also this IC by accident, and I'm just utilizing them to create a crappy synth. So that's like what we are working on currently. Okay, JC. Which color? I love the white color. I love boards with the white color here. I love it. Yeah. But it's too classy for like cramp. It has to be yellow if it's a cramp. Oh, okay. So I really not familiar. I was familiar with another software. I tried Fritzing and KiCad. I had KiCad on my old PC, and Easy IDE is so convenient. I just don't need the software, and I have huge libraries and huge user libraries that support almost every part. So it's sufficient for me. I don't do like multi-layer boards, like just 2 layers are for me enough. And it supports 4 layers and more, but I never use that. and it's good enough for my purposes. So I don't need like super fancy tools analyzing stuff and stuff like that. It's like hobby level, it's perfect. You don't need anything else. That's my opinion. And even if you don't order at JLC, it doesn't matter. I use the Gerbers also outside JLC. Okay, order it. Yellow. Yellow, is it? Is it yellow? Let's keep it yellow then. Stencil. We need stencil here. Top layer stencil, size, custom size, and we want like 14 or 16, 14 centimeters by 14. No, it should be more. 16 by 14. 16 by 14. And this is all okay. $9. Save to cart. No need to assemble this. I will do it here. Do it live. Okay, this is the first board. We can close this window. Stress. What do you mean with stress and analysis? I do you the favor. What the hell is reliability? have to have to read this later. Oh, yeah, basically, um, usually it's like only logic, so there is not much current, and voltage is always like 5 or 3.3 volts, and yeah, the only like edge cases where I like communicate from 5 volts to the ESP32, which runs on 3.3 volts, so TTL logic and CMOS logic mixed, but the ESP32 is quite tolerant on that, even though they don't specifically state this. Yeah, but if it doesn't work, if it blows up, I will see that. I don't have like to create. I'm not like I'm not creating medical devices or automotive or something. And probably at the end, the least reliable parts will be like the ESP32 boards themselves, since they like to crash on some occasions or whatever. So most probably, it's not like yeah, it's mostly logic. It's not like I do like power regulation stuff or like that. If I use like for my LED wall or something, then I just get the ratings for the power supply and calculate the maximum and put something on top of that, and that's what I use I do like only calculations, but not like simulations of the whole system if it like oscillates and creates like high voltage peaks at some point and like blows up stuff. Yeah, I understand this. I was writing software for medical stuff, so I completely understand that it is like an issue, and it could be an issue. Yeah, please grill me. Oh. Okay, one board is ready. Should we try to? Oh, it's getting late. It's 3 already. Maybe we will postpone that one here. The MIDI synth. Shall we try MIDI synth or do another version without the resistor ladder and the stereo version of that crappy board that we just ordered? So it is even like breakout boards. How do we clone this? Clone. There is a clone. Whoa! Personal. Okay, and there is a clone. Breakout copy. Rename. How do I rename it? Edit. It's cramp deluxe. MIDI cramp deluxe. Is this a okay title for that one? Yeah, it is probably. So let's reload. Okay. RF stuff. Oh. So what kind of medical devices are you working on at your work? Angel or Angel? How's it spelled? I don't know where you're from. So MIDI cramp deluxe. Let's replace the resistor ladder and this amplifier stuff here with something else. So we don't need this female header here. Oh, NDA, okay. Yeah, I got that. Okay, that's all we needed to change here. Now I have to be careful that I take the right pins for the I2S. There are some DMA, thingies. Do we have here DMA? Maybe we could even use DMA. IRAM, DMA. Here. Anyone reads Chinese? DMA, 5-4, DMA, that's the timer. DMA bus. That's the datasheet of the USB chip. Yeah, I will do like a manual I2S thingy here. Let's just pick any GPIO. Okay, we have like PWM here. analog in, that are analog in channels. LED, LEDC, interrupt 0, SCS. Any suggestions? Yeah. If I had a second try on my life, I would learn. I don't want like to offend anyone, but I would rather learn Chinese than French. I didn't have many occasions in my life where I needed French language. So suggestions, which GPIOs we should use for the I2S stuff? I think I will take these two here. But we have like analog stuff. Imagine we could filter like do like analog input and then like a real-time vocoder with the MIDI stuff here. Oh, I see some possibilities. Analog inputs. What up? Hey, what up? What for? Why should I ditch it? You know, I could ditch it any times. Oh yeah. I even have like this data sheet somewhere on my hard drive. But I won't read it right now. It's not very entertaining for you to watch me reading datasheet. But you could like, if you are like super into it, you can maybe check out which pins I could use for I2S there. There's no built-in I2S in this chip, but like DMR bit banging or something. Okay, what do we have here? Data, so it's like data and clock. And word select. We have like clock and word select. Word select. Is this not word select? Yeah, something like that. We have like 3 lines, 3 outputs. Oh, yeah, but these are only like... Oh yeah, we can use these 3 here. That's like data on this pin, word select on the last pin, and the clock here. How about that? Fewer components to dick around with. Okay. Let me show you the possibilities here. Why do we have like 2 PCBs? What the heck? Uh-oh. Oh yeah, I can delete that one here. Delete. Okay. No, deleted the wrong one. Where is it? It's gone. What? Oh no, that's right. Oh, hey, please. It really scares me sometime here. It changed the order of the projects. Yeah. Okay, so let me show you something. Okay, the ladder is too big for you, isn't it? Okay, so why don't you just use the first like 1 bit, 2 bits, 3 bits or whatever and short the rest? No worries. You can make it simpler anytime. So look at this. A0, A1, if you want to use 2 bits, or let's say, oh yeah, that's inconvenient. A0 is inconvenient. Okay, because you have like to, okay, let's shift. Okay, let's use only A3 and A4 since these are the most significant bits of this port. A3 and A4, so we will use these here and simply leave this disconnected and short these ones here and short these ones here and leave this disconnected, and we have a simple simplified 2-bit resistor ladder. Yeah, or populate it with 0 ohms, or simply do a solder bridge there, or like a thick wire across this. So I could simplify it if I wanted to. But remember, I want to do some, at least with ADSR, like some volume control there. I don't want like PWM quality stuff there. I want real like ADSR with like without any clicks and stuff like that. So it will be noisy anyways, but yeah, since I just copied the resistor ladder, it's okay. But you are right. You are right. Might want like a super simple one. Six bits, yeah. Okay, yeah. Yeah, but you don't need to populate all the bits if you don't like to have them. Since, yeah, it's even in the code, it's digging around with all the different ports here. You have like, there is not even one port with all 8 bits available. So even here with this one, why did they do this? There's 3 missing. You have like 2, 4, 5, 6, 7. Why? It will be like one shift operation or something to use like these 5 bits, but 3 is missing obviously here. And it's nowhere to find. I can't find it. And you have like here 3 bits that are consecutive. And here you have like 2 bits that are, that's, so at least the T version of this chip is crappy. Okay, so we have the deluxe edition here, and we want to add like a proper amp here. We have this PAM, boop, like this. Oh no, we want also, okay, let's start with this one here. Boop. And we have like this, the output jack. Oh no, we have the output jack already here, but we can use like the, oh, which one is the left and which one is the right? Okay, let's remove this and add this instead. Clone. And now we need only the, which one was our PT whatnot? Oh, this one is out of stock, but is this the one that I have around here? PT 8 to 11. PT, yeah, that's the right one. BT8 to 11. So we add from the libraries. To 11, let's search it. Audio kit. What? Yeah, that's user contributed, but we have also like here. Oh, interesting. What? That's not the right one. No, I want this one here. What's that? Here. Nice, isn't it? Let's place it here. Cool. Not connected, okay, so let's put the data in. Data in. Ground. Okay, we need some filtering, don't we? Word select. Base clock. And then we have right channel and left channel. And these are left channel, right channel. Not connected. Then we have ground. Bloop. And we have 5. Welcome to the noisiest DAC that's in existence here. Done. New board created. No resistor ladder needed here. Much fewer components. Okay, let's take a look what kind of filtering they need here. 47 microfarads. Are you crazy? But this 10 ohms is interesting. I don't know if I have 10 ohm resistors around. I have to check this. Okay. I actually don't have 10 ohm resistors. Hello, Mukund. Okay, 10 ohm resistors. So I will put 10 ohm. I have only like 0805 footprint 10 ohm resistors here. Lowest price. Oops, you can't see anything. So we have like, that's really cheap, isn't it? Ever ohm tech plus minus 5. Okay, look at this. It's like the difference. Okay, it's like it's like 40% difference, but it's so cheap. Why shouldn't I take like 1% instead of 5%? What's a complete real? Cut tape in stock. Oh, there's only. Oh, okay. 4,200 in stock. So if I take all the 4,200, then I will get the complete reel. Cool, isn't it? Add to cart. Done. Is it 10 ohms? No, it's 10.2 ohms. I almost bought the wrong ones. Why? Oh, crazy. No, I want 10 ohms, not 10 point what not. Where is my 10 ohms? I need to filter here. Resistor networks. Ooh, chip resistor surface mount. Yeah, that's bad. Yeah, I don't have anything close here. I don't know, maybe there is like, yeah, but the next town is like half an hour drive from here. I wouldn't drive there. Even in Darmstadt, there wasn't like an Conrad Electronics. I would have to go to Frankfurt. Okay, 1%. Let's filter the crap out here. Oh, yeah, but there's not much here. Look at this. There are even fewer available. Funny. Okay, I take all. 5-0. Okay. So we take like 10 ohms here. We do like some nice filtering, power filtering. No, not libraries. So do we really need this power filtering? What do you think? It's crazy. We should do like a super simple one without the filtering. I feel like it's like complete overkill since this one isn't filtered either. Either. We have like here 10 microfarad and that's all. Yeah, but that one needs all the power. Okay, yeah, I can populate it with 0 ohms if I need, or any other value that's lower than 10 ohms. Okay, let's take 10 microfarads because any other stuff won't be like VDD, and then we need some ground here. So this is our power filter, RDC, LDC, no output filtering. Okay, now the moment of truth. This if this capacitor that's the base, I want to have my base saved. I don't know if this destroys my base. We need to drop the base. Oh, I have to check if I have 1 micro ohm capacitors here. I should have. Microfarad, not micro ohm. Yeah, I have a complete reel. There is a complete reel with 1 microfarad. Okay, is that all? Is that all? I think we have everything. Should I break out all the pins? The remaining pins here? No. I didn't do it with the others as well. Who cares? Okay. Design manager. Let's check. Oh, what's... Oh, we have like an amplifier enable. Ooh, fancy. Okay, yeah, let's do an amplifier enable here. Amplifier enable. That will be a mess to set this up. We don't get anything out of that. What's enable again? Oh. What? Oh yeah, that's... Oh, we have enable here. That was amp enable. Okay. That was a similar one. Gain. Yeah, we don't have gains here, but we can gain. That's great. That one has an additional gain. So we will take like 2 consecutive bits for the gain. Okay. 2 consecutive bits. Okay, these ones here. So we have actually, we need some additional pins, but the gain pins are quite cool. So this gain control. So we can like change. Ah, oh, come on. Set this in software. However this should work, I don't know. Maybe we should only put in like resistors to pull it down or up or whatever. But we can also like no, we can use MIDI for that. Is there a volume? Yeah, we use like some control to set the gain. If you use like different types of headphones, you can adjust the gain. Okay, cool. Gain 0 and gain 1. Is that all? What's that? Oh yeah, that's not... Boop! Okay, see you, Angel. Yeah, you too. Okay, I think we are done with the schematics. Did I forget anything? I did some crappy... Okay, we can maybe add another, like... Yeah, but no video on the main channel for like 3 weeks. I really want to do more streams now. I think it's very rewarding since it's not much effort to set this up for me right now. But I'm not sure what when the next day is, when I will be able to stream again. I have to do like a contractor work tomorrow until Thursday, and I will maybe do like video editing, so not PCB design, but writing script and sharing like how I create a video, if that is interesting for you, to you. Okay, 100 nanofarads. Okay, I did this filter as well. Okay, so we did everything we could, guys. There is nothing left to do better here. This is really luxury with this polyfuse even here. Okay, great. No electrolytic caps. No one needs that. Let's create a PCB. Oh, yeah, we have update PCB. Let's see. Apply changes. I hope. Yeah, okay. Oh, wow. Look at this carnage here. Is this even the right one here? I hope. Yeah, it's MIDI cramp deluxe. The name. Oh, okay, let's deactivate the copper areas first. No solid. No solid. How is my voice? Is the microphone behaving or is it pitched down again? Like always after some time. Top silk layer, bottom silk layer. Okay, we want to see. Oh, what's that? Oops, I deactivated the. What? Where's my? Oh, okay, yeah. Okay, let's leave the top silk layer then. Okay, let's remove all the wiring that we don't need. Then what's that? I'm confused. Oh, yeah, that's another IC. But how comes this is placed like in the middle of the middle of something here? Oh, interesting. They even replaced the audio jack. Oh, we don't have this connector. Oh, that's like a cap. Oh, that's the wrong cap. Or what is this? What is this here? C10. Oh, we have the wrong style here. Where's C10? C10 is, oh, what the hell? Oh, which one was this? 1 microfarads. Okay, so probably on the other MIDI synth, this is as well. Yeah, that's also the wrong type. It's maybe not healthy to switch between all the. Okay. Take over, apply changes. Okay. MIDI cramp deluxe. Okay, all the vias be gone now. Do not want. Clean up here. Like this. Go away. Okay, see you soon. Oops. Yeah, I could probably leave these here, but I will place them later again. Like this. Then the panelizing, turn this off. Bloop. Oh, the red wires are making crazy. Driving me crazy, sorry. Okay, so now that we don't have the resistor ladder, we could move that here. Okay, let's change it a bit. So the problem is we want to have this on the edge, but we need this 1 millimeter. Let's do snap grid, snap size 1 millimeter. No, that won't be helpful. Wouldn't be 2.5. No, that's shitty as well. 0.5 millimeters. Okay. I will remove this point and this point. Yeah. And now add like a cutout on the other side. So it won't matter on the panel anymore. Like this. This is crazy, I know, but that's optimization for production. So what is the placement here? Like that. Even more. No, that should be okay. This is enough. And here mouse is 25, 26 is 6.5. Okay, like that. Okay, this is what we need. So since this port has an overhang and I want it closer to the, for the case to be reachable, I do the cutout on the other side. So when we panelize it, it can be picked and placed with the overhang, and the overhang will go in this this cutout here of the neighbor board without problems. It looks shitty, but it should do the job. We have the space now here. We could make it smaller now. Oh. You know what? We make it smaller. So we want to do like 3, yeah. We want this line here to be at 30 millimeters. Okay, so we will try to shrink it a little bit more, but we have to rewire everything now. That's unfortunate. Otherwise the jack will not fit anymore. What was that? Oof. Okay, grid size. Like, oh, canvas attributes. Grid size is 1 millimeter. Update. Okay. What What? Oh, yeah. I'm confused. Isn't that centered here? Uh-oh. This is off center. Oh no. That's... I thought this is centered. It wasn't. Oh shit. Wait, maybe we have to modify the other board a little bit. I don't want to be it off center. I hate that. Oh, come on. Yeah, let's leave it like that. Actually, it's quite relaxing job to do. It's like you don't have to do like complicated stuff. It's like this is like a complete product. So if you do like a super simple work, I wouldn't like to do it for living all the time. So like it might be, I might end up being bored or something. But for some time, like it's interesting from time to time to do this. Okay, now I will just remove all the wiring that sucks. I don't want to mess around with these traces here. It's crappy. Okay, maybe I will leave these here. I don't want like these here, this crap. Okay, I can leave this one, this not. Button, reset. Okay. And I only click up and it snaps to like another point. That's shitty. Yeah, let's remove this. Oof. Let's remove this crap. There are probably better tools than this one, but I really... Oh, did I just remove the label? Yeah, I did. Come on, come on. No, I can't select this without touching the label. Okay. It's like a bounding box or something. So how do I center it? Where are we here? This is the board is 25. Oh yeah. So we need a grid, not every millimeter, but every half a millimeter to center it properly. And we need 2.5 snap grid here. Okay, so this will be finally centered. So 2.12, 15, it's like that here. This is centered now. And that one, we need to move this up like that. And what's the position of that? Yeah, that's okay. Now, oh yeah, it fits. If it fits, I sits. So this is even a smaller board. We can do like three rows on one PCB. That's convenient. Let's keep the labels here. This is all right. Don't need that here. USB. Okay. There's a much better product at the end, probably. How do I rotate it that it's will be okay? Like, do I use it like that? But these are like two different caps here. This where this one, where does this one belong? Oh yeah, that's that one here. And that is the fuse. Oh. Okay, you know what? I remove this one and rotate that. Do we have a ground here? No. Not yet. It's like that. I'll move it over here. Is there enough space? That would be everything on the bottom layer. Yeah, breadboard. Yeah, probably fine. Yeah. What I don't like about breadboarding is that everything is janky at the end, and sometimes it doesn't work, and you assume it's like your circuit or something, and then it's just like a super janky, cheap ass jumper wire, or like a bad connection inside of the breadboard, and then you mess around for ages, or you touch it, or you move it and you disconnect something, and like after a year you don't know which wire goes where, and yeah, maybe once you're done with your circuit, you can formally coat it or like dip it in resin or something to preserve it, and then it's like an artwork. That should work. That's a quite good idea, isn't it? Yeah. 100 nano cap, so no need to display the name. Nope. And the fuse is a little bit janky. It overlaps too much. I will move it over here. That's ground anyways, so I can move it up there. And the 5 volts can go up there. It's like this. This could work. Yeah. Oh, it's really cramped up there. Oh, the capacitance of the breadboard. Did you have, Christian, did you have had something like that in the past? Like it's like the rails with the power on the side is like a cap. Like that's cool. Yeah, that's something no one would ever expect, isn't it? Yeah, that's a nice way to place power directly next to the oh, what's that here? not USB 3. What's that? Yeah, just really close. Now I will just move the label. Oh, I don't like this. Everything so janky here. Okay, so rewire it now. Okay, and rewire this one. Okay, so this is the 200 ohms resistor. Then we have that one can move as well. Do we need to move it? Or can we leave it there? What's that here? It's crap. Don't need that here. So what's this one here? Oh yeah, that's the power filter. Oh, that's the PAM. Oh, this is the DAC. And this is the... What's happening here? It's interfering with itself. And like, there's not enough clearance between the pads. What? Are you kidding me? Okay, I need to change the design rules here. Clearance. What's the minimum clearance for JLC? Oh, I'm getting really tired right now. It's time to go to bed. No. Shall we continue another day? Clearance. So what do we need? .5 mil. Is this the right one? No, I can't find clearance. How much is 3.5 mil? So what, 1.2? No, 3.5. Nah. So, okay, so we need to change to mil, then go to design rule and set to 3.5 mil. Let's set 4 mil, okay? Don't need to be like super greedy. And it's done. High speed op amps, yeah. Oh yeah, you know what? This is an high amp op amp here, like it's like on this, it's 200 megahertz, and yeah, it doesn't work. Or it doesn't help, let's say. I thought it would help with the analog signal with the external resistor ladder, but it doesn't. The color isn't still going. Yeah, I'm making a new board. The first one is already in my basket, but I think the connectors are off center. And now I'm on a new board without the resistor ladder and an external DAC and like this small stereo amplifier here. So I'm doing like only boards, but I think I will go to sleep quite soon because I'm super tired. I'm getting slow. Yeah, we don't need this one here. Wow, this is so tiny. How do I solder something like that? I didn't know that this one was so tiny. Okay, and I maybe need to switch the places over here since I have some control pins to handle, and this is the, okay, this isn't needed here. This is just some power filtering that's not quite, doesn't need to be quite close to anything. We need to add there the deluxe. That's not necessary for now. Okay. Whew. The red wires are driving me crazy. Okay, it's 4 o'clock now, guys. We are going for ages. Maybe I will continue this one here. Okay, I check. We are streaming for 3 hours again. Oh. So it's 6 hours for today is enough, I think. For today, it's the night shift. So Christian, are you also watching Sion struggling with his boards? How many viewers are there? Oh, 10 viewers. Yeah, everyone is sleeping at the moment. Only Sienna is like on the toilet or something. Yeah, but this one actually will fit quite nicely. Like 3 row, it will be super tiny and could be really nice. I don't know if I even bother doing the other one, but this will be quite some challenge to code since the 16-bit, and I don't even have like, okay, I don't need to use 16-bit for the audio, or I use like a super small buffer, like super small buffer. Okay, rotate it. Does it resolve anything? I'm not sure. Oh, the gain. Oh, it's swapped here. It's super sucky. Okay. Oh no, so many pins. Where does this one go? What's this anyways? 5 volts and you. Oh, that's the resistor, isn't it? Is this the resistor? Yeah, this is the 10 ohms resistor. Display name, yes. And it should be a small font. I'm only streaming because I want to get the 3 hours complete here. So this is the power filter. So we get 5 volts from here. We can at least place the components. We don't need to wire it. We can continue tomorrow. So this is 10R, like. And this one here is the filter cap for that. So maybe let's move it down somehow. And this is the 10 microfarad filter for that. Like so. And we have another 100 nanofarad filter. Where is this one here? Like a cap here, this one. This is the 1 nanofarad. Yes. 0.6 and 0.2. Like that. Why is this font bigger than this? This is already janky again, like super janky. It gets easier every time, yeah. Oh, that's 0.8. Let's do it 0.6. Okay. Where's this coming from? U2. Yeah. Yeah, I don't need to display this. We don't have any similar parts. Yeah, coding. Coding is a bit simpler. But this is fun, actually. Doing this is quite fun. Don't you enjoy it? At least watching me doing it. You will enjoy me like placing this by hand. Okay. Yeah, no. Okay, let's place the all the caps. Why? Why do I need to do this? Take the caps won't fit there. I need to switch to 0.0402 components. No. Okay, smaller. 0.6. Doop. 0.6. Doop. And move that up there. No one will notice. So we can move these parts here, and then we have a nice power filter. Oh, doesn't that look great? Guys, that's awesome. Okay, fine. 10 micro, 10 ohms. Then we can move this up here. And maybe at some point in time, somewhere far, far away, where this, what's disconnect? Why don't I see anything here? What are these connections here? C11 and C31. Hey, what's with that? Are these like caps somewhere? No. This is, oh, this is another filter cap. Oh no. Give me a break. Schadenfreude. Oh, nice word. Cool. Or I put this somewhere else. I don't look. This IC, this is the D class. Is this correct? Or is there something wrong with this footprint? Is this really smaller than a 0603 component? No, not smaller passives. I need these huge passives here. Okay, I will put them like so and hope it will work. Like this and that and here and this. Okay, maybe not. Yeah, but it's not, there are not many components left. So, or we could move the fuse up there. Then move this chip over there. No, this won't help. We can move this one there and move this one down there. Okay, but I will check if we have the right size here of this IC, because it looks a little bit tiny. Not that we have like the wrong, where is it? Wow, it's only 2.5 millimeters. This is crazy. That's so cool. Such a small device. 2.5 millimeters. I love this IC. I love it. But it's not very cheap. Look at this. Wow. It's like, okay, for 100, it's like 30 cents per piece. This small amplifier. Does no one like a nice alternative to that one here? But it's really 2.5 millimeters. Crazy. Hi, DevBomb. Yeah, you missed all the stream. We are almost done here. I just asked because I was wondering about this footprint here. This Class AB amplifier is 2.5 millimeters wide, and was wondering if this is correct on my in my design here, because it's like, okay, so we have, it should be one, yeah, it's correct, it's the correct size. We have 0.5 millimeter grid, and that's as big as my resistors. Wow. Oh no, I don't want to switch to 04 or 02. I don't have a microscope. Really don't want to like super finicky small stuff. Audio is quiet. No, it isn't. I am at minus 12 dB. What? Maybe you turned down your volume or something. Yeah, it's a small part, isn't it? This complete board, like this is a complete MIDI host synthesizer class AB amplifier with like an additional connector for power, and it's like 2.5 centimeters by 3 centimeters big, without like this overhangs here everywhere. Oh. Okay, guys, enough for today. I was streaming like ages now. Thank you for being along here. I forgot how to speak. Yeah, for joining the stream. It was a blast. Chatting and streaming and creating new boards with this like JLC off-centered connector board here. JLC, no, that's... Yeah, it's not signed in. Okay. And I see you next time. Bye. Where's my chat window? Awkward, last. Well, just look in the chat. The weather is cranked to 11. Yeah, it is. So see you next time. Bye. Oh, show my face. Show my face in big face. Or do we do like power up? Oh, there it is. Power up. Is it playing? Oh, it's playing. Okay.